Welcome back to General Chemistry 1. I'm Dr. Fang Xu, and today let's talk about dimensional analysis. This is also the last topic in Chapter 1. When we talk about dimensional analysis, we are actually talking about calculations involving dimensions. I know some of you may not be very comfortable in doing calculation, but you should firmly believe that all the calculations can be done. And don't be afraid of it. Find out what is needed to solve the question step by step. Be patient and careful, and you can have it done. Let's take a look at this question. This is the question from the textbook. The volume of an irregularly shaped solid can be determined by the volume of water it displaces. A graduated cylinder contains 19.9 milliliter of water. When a small piece of galena, an O of lead, is added to the cylinder, it sinks and the volume increases to 24.5 milliliter. What's the volume of the piece of galena in cubic centimeters and in liter? Okay, when you read through it, there's so many informations, but first you need to know what it says. It says the irregular shape, put in the water, some water, the water volume will increase in the container. So you should get the information that the increased volume of water should match the volume of this irregular shaped solid. It asks for the volume of the piece. So we need to find the volume of displaced water. And from this question, the volume increased from 19.9 to 24.5 milliliters. So from this case, we can get the volume of galena by using 24.5 minus 19.9. The increased volume from water is actually the volume of the solid. Now we have the unit. So please pay attention to unit in all of these calculations in dimensions. It's in the unit of milliliters. What it asks is in the unit of cubic centimeters and in liter. So we need to do the unit conversion. Unit conversion is everywhere. We need to find the conversion factor. 1 milliliter equals to 10 to the minus 3 liter. Remember, milli means 10 to the minus 3. And also 1 milliliter equals to 1 cubic centimeter. We use the box method, put 4.6 milliliter here and 1 milliliter in the bottom. If we want to go for the cubic centimeter first, we use this set of unit conversion factor. So we put 1 cubic centimeter on top, and this is now answer in the unit of cubic centimeter. We can do the same thing to convert unit in liter. 4.6 milliliter, which is the first unit conversion factor set, 1 milliliter in the bottom, and 1 times 10 to the minus 3 liter on top. Do the calculation, and we have this value as the in the unit of liter. Please pay attention here. We follow the rules of uncertainty when doing subtraction. Okay, 1 digit after decimal. And when we do the multiplication, we keep the rules to keep the smallest digits of significant figures. The unit conversion factor does not count. All right. This is just one question involving dimensions. There are some other questions that were involving density. So then we need to talk about the equation that involves density. For example, if you have some liquid water in this kettle and you boil them all the way up to just the water vapors, imagine it's still the same amount of water, it's just turning from liquid to vapor. And obviously, vapor has a larger volume than the liquid, right? But the total mass does not change because it's still the same amount of water. So what is changed is the density. From this case, you can know that density times volume equals to mass. The more density it is, the smaller volume it is if the total mass is not changed. In other words, we can use this symbol to express this equation. Density equals to mass over volume, or volume equals to mass over density. So these are the basic mass transformations of the equation, and you are also expected to be able to do this. Let's take a look at a question involving density. Besides, all the preparations we have for the previous questions, there is a trick when you do the question involving density. So you try to convert units of mass and volume. If you need to do it, you need to do a unit conversion. Convert units of mass and volume to the corresponding units in density. Don't try to convert unit of density because it's very complicated and it's easy to make mistakes. For example, here we have two questions. So first, lithium, it's a soft gray solid with the lowest density of any metal, is a key component of advanced battery, such as the one in your laptop. The first sentence is just a background information. It does not offer you any valuable numbers in calculation. Okay, from the second sentence, a slab of lithium weighs 1.49 times 10 to the third milligram and has sides that are these three values. Find the density of lithium in gram per cubic centimeter. Okay, so if you're asked to find the density of lithium, you need to think about the density equations. Density equals to mass over volume. So do you know the mass of the lithium? Yes, it tells you 1.49 in the 10 to the times 10 to the third milligram. Do you know the volume of lithium? It does not tell you straightforward, but tells you the length of length, width, and height. It's a slab. So you can calculate the volume of a slab by using length times width times height. Okay, so it seems to be we find the mass, we find the volume, and we can calculate the density. But always, 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 you need to be careful about the unit. The density wants to have a unit in grams per cubic centimeter. The mass offered in the question has a unit of milligram. It's not in a gram. So we need to do the unit conversion of that. And also for the volume, it offers the side in millimeters. We want in centimeters, cubic centimeters, right? So we can convert all of these millimeters in centimeters. Now we can match the units for mass, volume, and density. All right, now let's solve the problem. So we need to do the unit conversion. So get all the units ready. We convert the milligrams to gram. We convert milliliters to centimeters. We convert, another milliliters to centimeters, and also length, width, and height, all of them. So now we have all the units ready. We can calculate. The mass is already done, right? So we can calculate the volume. The volume is can be calculated by using length times width times height. So altogether is 2.760681 cubic centimeters. I did not round off in the intermediate step. This is to avoid errors accumulated in the intermediate steps and lead you a large error in the final answer. So always try to be as accurate as possible in the intermediate steps. And then we can calculate the density that equals to the mass here divides the volume here, and the unit matches. So we don't need to do any unit conversion for density. Get the final answer, run it off to match with the rules of significant figures. Okay, so this is the final answer of density of lithium, 0.540 gram per cubic centimeter. It asks another question. B, what is the volume? Define the unit in milliliter of a piece of lithium with a mass of 895 milligram. It asks you about volume. So there are many ways to get volume. Like before, you can get the length times width times height. But for this one, it does not say this piece of lithium is a slab. It could be an irregular shape. And for those cases, we can use the transformed density function. The volume equals to mass over density. It tells you the mass, great, and it got density before. So for the same substance, the density of the substance does not change, right? So we can use the answer in the first question to do the calculation. All right, so mass here is in milligrams, but in the density unit, we have a gram, right? So we need to convert the unit of mass to the gram. And after we get the volume, and then we can convert the answer to the required milliliter unit. Okay, so let's do it. Using the box method to convert the unit of mass. 895 milligrams can be converted to 0.895 gram. Then we can use the density equation. Volume equals to mass here over density. So I used the number before rounds off in the previous question to maintain the accuracy. And then we can have the volume as this number. Because we haven't do the unit conversion, so I'm still keeping a lot of decimals in the intermediate steps. So typically 4 to 5 digits after decimal, I would say. And then we can convert a unit of volume to milliliter. Again, box method, convert that to milliliter. It's the same value. Luckily, it's 1-to-1 ratio. So the final answer after rounding off is 1.66 milliliter. That's the end of this video. Hope you enjoy it, and see you next time in chapter 2.